So this is a problem that was asked over email in section 6.7. And in section 6.7, what you're doing is you're solving. The problem is they give you 9 over 11 minus 1/3 equaling x over 9. And the directions ask you to solve. There we go. It's a little better. Okay, the difference between solving and adding and subtracting, because you spent some time in section 6.4 and 6.5 where you're adding and subtracting. And adding and subtracting, you're basically trying to get a common denominator and then get the numerators together once you have a common denominator. So you're just simplifying when you're adding and subtracting. When you're solving, the difference is you actually have an equal sign in the problem. So when you have an equal sign here, what you actually want to do is clear the fraction. And once you clear the fraction, then you can solve it just like usual. Okay, so what we're going to do here in order to clear the fraction is we're going to identify what's the common denominator between these. Okay, and the common denominator, if you take a look at 11, 3, and 9, if you think of 9 in its prime factored form, it's 3 squared. Okay, so if I identify the LCM, for these numbers, for basically 11, 3, and 9, the LCM is going to be 3 squared times 11. And the way I'm getting that is I'm saying, well, there's two factors in the problem. There's a 3 and there's an 11. And 3 occurs twice here, once there, and no times there. So the most it occurs in any one factorization is twice. Okay, so I need it twice. And then for the 11, it only occurs, here once, 0 and 0. So I need it once in my LCM. So 3 squared is 9 times the 11 is 99. Okay, when you're solving, the LCM is actually the same thing as the LCD. Remember, LCM stands for the least common multiple, and the LCD stands for the least common denominator. When we're looking for the least common denominator, I sort of use them interchangeably. It doesn't really matter which one we use. What we really want is we just want this number 99 because we're now going to multiply everything in the problem by 99 to clear the fraction. Now, how this is different is previously, if it were just this problem where we were adding or subtracting, we would just be getting a common denominator of 99, and then we would call it good. Okay, but now we're actually solving. So the process becomes a little bit different. What we're going to do is take 99 and multiply it by each of the terms in the problem, and that should clear our fraction for us. If it doesn't clear the fraction, then we've made a mistake. Okay. All right. So now I can do some canceling. I see that 11 goes into 11 once, and it goes into 99 9 times. And I'm left with a 9 times a 9, which is 81. Oops. And 9 times 9, which is 81. And then here, 3 goes into 3 once, goes into 99 33 times. I'm left with 33 times 1, which is 33, and then there's a minus sign out front, so that's 81 minus 33. Here, 9 goes into 9 once, into 99 11 times, and I'm left with the 11 times x, so that's an 11x. Okay, so what we want to do now is do this subtraction, 81 minus 33. I believe that ends up being, let's see, 48. Is that right? 81 minus 33, 11, 8. We need to borrow from there. 48 equals 11x. Okay. And then from there, we're just going to divide by the 11. And so we get x equals 48 over 11 as a solution. Okay, now when we're actually solving, these rational expressions, we need to take this answer right here, and we actually need to check it in the original problem. So we need to take it back up here and say, does it give me 0 in a denominator? and it doesn't because these are actually all numbers. So therefore it is a solution. If I took that number back up and it gave me 0 in a denominator, then it would not be a solution because 0 in the denominator is undefined.